Ask My Instructor 6.6.31. The figure given shows the shape and dimensions of a small dam. Assuming the water level is at the top of the dam, find the total force on the face of the dam. We're going to use 1,000 kilograms per cubic meter for the density of water and 9.8 meters per second squared for the acceleration due to gravity. Now, if a vertical wall is immersed in water, then the hydrostatic pressure on a horizontal strip of the wall is the product of four things: the area of the strip, the density of the water, the acceleration due to gravity, and the depth of the strip, how far below the surface of the water the strip lies. We're going to put the base of our dam on the x-axis and place the y-axis up the middle of the dam. For each value of y, we place an infinitesimally small horizontal strip. The thickness of this strip is infinitesimally small. The width of the strip is going to be from one side of the dam to the other, and that length is going to be constantly changing. The hydrostatic pressure on the strip is the area times the density times acceleration due to gravity times the depth. So we're first going to set out to find the area of the strip, and that's actually our most difficult piece. Now the thickness of the strip is dy. That's infinitesimally small thickness. And what is the width of the strip? What is the length from one side of the dam to the other at the value y? To find the width at y, we're going to first find the equation of the line through the points 3, 0 and 6, 9. So the line that goes from one corner to the other. The slope of the line is 3, and then we use the point slope form of the equation of the line to find the equation of the line, and then we just clean it up to get y equals 3x minus 9, which describes the blue line that goes between 3, 0 and 6, 9. Now, we're going to solve for x to find the distance from the y-axis to the line. If y equals 3x minus 9, then that means that x has to be a third of y plus 9. So, at the location y, the distance from the y-axis to the line is 1/3 y plus 9. And that tells us that twice the distance, that is w of y, twice the distance would be 2/3 y plus 9. So for a given y, the area of our strip is 2/3 y plus 9 dy. Now, what about the depth of the strip? How far below the surface of the water? The water reaches to the top of the dam, so the distance below the surface of the water is going to be 9 minus y. Putting all this together, we get for a given y, the hydrostatic pressure on the strip is the area times the density times acceleration due to gravity times the depth. Now, we found w of y, and that w of y was 2/3 y plus 9. We also found h, the depth. The depth is 9 minus y. Then what we do is we take y plus 9 and multiply it with 9 minus y, just to clean it up and make the integration that we have to do more easy. So we do that multiplication. Now this is the hydrostatic pressure on one strip, where the strips run between y equals 0 all the way up to y equals 9. To find the total accumulated pressure, we're going to have to integrate. So we integrate, we take all of the strips, the hydrostatic pressure on each strip, and add them up with y going from 0 to 9. Well, we find the antiderivative. That's not too difficult. And then we evaluate the antiderivative from 9 and then subtract the evaluation at 0. And after we do that evaluation, we put in the value for rho and g, and we get our final answer. And that would be in newtons. So if you have any questions on this, let me know. Otherwise, have a great day. Take care.